Hi everyone, welcome for another video. So today we're gonna try to solve another famous Leetcode question. So on the topic of arrays, so contain duplicate. So it's been asked by multiple big tech companies. So let's go directly through the code and see what's up is about. Alright, let's go. So we are given an integer array nouns, return true if there is any value that appears at least twice in the array, and return false if every element is distant. So it's quite easy. It's a very easy problem. So let's just go here and have it that way. So it's quite easy, and it's also really easy to understand what the problem is about. So basically we are being given an array of integers, and we have to find if there is an element that is being duplicate inside. Okay, and if it's the case, we just have to return true, and if it's not the case, we return false. Okay, so immediately, is there any constraint? No. Here in this problem, for example, we are not being given any restriction, so we can solve it any way that we want. So what's the best way to solve it? So immediately the first thing that can come in your brain will be, for example, to sort the array. If we sort our array, for example, let's say that we have so we have 1, 2. Let's say that 2 is being repeated there, and we have 3, and sorry, my bad. Let me just remove this one and this one. So we have 1, 1, 2, and 3. So if it's sorted, so if our array is sorted, so it means that if an element is being duplicated, it means that the next element that will follow up will obviously be the same as the previous element. And if that's the case, we can say that, oh, okay, our element actually has a duplicate, and we can just return true to mention that we have a duplicate element. So that's like the first way to code that solution, and yeah, let's try to do it that way. So we have nums. First thing, we need to sort it and do a for I in a range of nums, and basically we will be checking if nums I equal to nums I plus 1. So here we'll be checking like that to avoid the integer and outbound. So if that's the case, we can just return true, and if it's not, at the end we want to return false. So that's it. Let's run it. Oh, sorry, my bad. All right. Okay. So as you can see, it passed. So okay, it passed, but at the lowest point. So let's see the time complexity of this solution. This approach has a time complexity of n log n, because we are first of all sorting our array, and we are going through it, so we have a time complexity of n log n. So is there a better approach that we can do to kind of like improve and do it in of n time? Okay. For this solution, for example, you can notice that we are not creating anything in our memory, so the space complexity is here of 1. So if we check here, our space complexity here, based on our space complexity, is actually better than most of the users here. So let's try another approach. So how can we improve it to maybe go from n log n to O of n? So one way to do it will be to have some kind of like hash a set. We can have our set. So basically we can have our set and go through our element inside of our array. So every time that we are going through our array, we can just put that element inside of our set here and check if the current element is currently present, is currently in our set. If that's the case, we can automatically return true and say that okay, we have found our duplicate. But if it's not the case, we add the current element inside our set and we move forward. At the end, if we don't find any duplicate, we can just return true, and the time complexity for that is O of n. And since we are creating a set inside, so we will have a space complexity of n, because you are mapping all the elements inside of our set. So that's it. And so let's try to write the code for that. So we can have hash set equal to set, and basically say for I in range of len nums, we want to check if nums I is currently present in our hash set, and if that's the case, we can automatically return true. If it's not the case, we just have to add it. So hash set dot add nums I. So let's run it and see. And as you can see, we have a better, as you can see here, we have a better time complexity with 96% better than most of the users. And as you can see, our memory speed has reduced because we are creating a new hash set inside of our memory. So the space complexity for that is of n, but at the same time we are improving the time complexity that becomes of n. Sorry. So that's it for this video, and thanks.